In Algebra 2, Section 9.1, we're dealing with exponential functions. Now, we're getting kind of away from equations, polynomial equations, where some of you guys are excited because I know some of you are a bit exhausted from constantly factoring and boiling out. But now we're straying a little bit away from that and going into exponential functions. So basically equations with exponents in them. Which will help, it will help you understand a little bit on how to convert it, similar bases. So once you get the hang of it, it should be pretty straightforward. And so we're going to start with just basically a basic exponential equation, which is y equals ax plus b. A can be 1, so that means it doesn't necessarily have to be a number in front of the number with the exponent, but definitely in order for this to be an exponential function, there has to be a power, a variable with a power, or just a power in it. In exponential functions are done a lot with money and dealing with predictions. So we have something called growth and decay. So the graphs on these ones kind of go and they shoot up, straight up, okay? And then they go ahead and shoot straight down. Okay, so it's not like a straight line. Exponential functions means it's slowly, gradually, and then all of a sudden it just goes really high. And you'll see what I mean when we're doing the graph. I don't mean to confuse you right now. But basically, if if b, this number, is bigger than 1, so it's a whole number, then I'm going to have a growth. And that means it's going to increase rapidly. Now, if that number is between 0 and 1, so not a negative, but a decimal, let's say point something something, or a fraction, then it's going to be decay. So that means it's going to be slowly decreasing and then an incredible amount of decrease. So that is growth and decay, and all based on this number right here. Not the exponent, but this number tells us whether it's growth or decay. Now, the property of equality, basically exponents are equal to each other, exponential equations, just like most everything else, is if their base is the same. If their base is the same, then they're equivalent. So if I have b to the power of x equals b to y, then I can essentially get rid of b because I know that's the same and focus on x equals y. What I mean is, if I'm solving for x, 2 to the power of x, and I have 2 to the power of 8, because their base is the same, they have the same base, 2 and 2, then I can say that x equals 8. Now that's pretty straightforward, but sometimes these exponents are going to be entire equations, and it's going to be a little bit difficult on how to solve it. So if you know the bases are the same, and sometimes you have to manipulate the equation, and you'll see what I mean. If the bases are the same, then I can ignore the bases and just solve for the variable. Alright? So let's go ahead and do an example problem. Well, a few examples. Let's start with graphing, which I know some of you are overjoyed in graphing in this piece class. We have our classic graph. Here, they want us to graph y equals 4x. It's the same type of thing as you want to graph others. You have your x, your y. Your x equation is the same, -2, -1, 0, 1, and 2. And of course you can add if need be, but we're going to stick with the basics. Then you're going to plug it in as normal, and then you're going to have y. It's just the graphs are going to look slightly a little bit more different. So if I have 4 to the -2, and remember your rules, and you should have them in your flipper, if you have a negative exponent, that means it goes on the bottom. So what I have is 1 over 4 squared, right? The 2 still sticks to it, except now it's now it's a positive because I've taken care of the negative. So I have 1 over 16. So in decimal, 1 over 16 is 0.0625. Okay? I'm going to do the same thing here. 4, -1, so that gives me 1/4. So that's the same thing as saying 0.25. Okay? I have 4 to the 0. Anything to the power of 0 is 1. So I have 1. That's also a rule. And it'll be helpful for you to have all the rules of exponents just in case. And then I have 4 to the 1, which then goes to 4. So you see what I mean? It goes from 0.625, 0.2, all like leading up to 1, and then it gets all of a sudden from 1 to 4. And then 4 squared, and then from 4 to to 16. So basically, if I want to graph, I'm going to do negative 2 is 0.625, negative 1 is 0.25, 0 is 1, and then 1 is 1, 2, 3, 4, and then 2 is somewhere up here. So my graph, it goes slowly, and then it just shoots straight up. And that's the equation of exponents. It's not a line, it's a really rapid increase curve. All right? Your next one that you're going to be dealing with is you're going to be solving these equations. Now, they're going to try to trick you, but again, the whole goal in the equation, it says that if the bases are the same, then I can focus on the exponents. In this case, the bases are not the same, but I could solve for it, right? I'm going to take 256, I'm going to take it to the side right here, and I'm going to see if I can put it in terms of 4. So basically, I'm going to divide it by 4 to see if it evenly divides a certain number of 4s. And I'll show you why we need to do that in a second. So 256, and I'm going to start dividing that by 4, which gives me 4 times 64. Looking good so far. 64 is 8 times 8. This gives me 4 times 2, 4 times 2, which these two multiplied together gets me 4, right? So that means I have 1 4, 2 4, 3 4, but I have 2 2s, but if I multiply them together, these together gets me a fourth 4. So basically, this is the same thing as saying 4 to the 4th. If I do 4 times 4 times 4, it should give me 4 times 4 times 4 times 4, it should give me 256. And this is 4, 9, and negative 2. So here we go. Now we can apply our equation. Because this base is 4 and 4, I can then ignore it and solve 9n minus 2 equals 4. So one more time, because once you get to this step, it's pretty easy. You just solve for n. But what I did is I manipulated 256 and started dividing it by this number because that's the base. Once these bases are the same, then I can go ahead and bring down the exponents and then solve. So from here I'm going to plus 2 on both sides, and I have 9n equals 6. So then I have n equals 6 over 9, which is n equals, I divide both by 2's, 2 over 3. Okay? So, go ahead and do that. I believe I did the work right, but if not, maybe somebody will catch me. The last one we're going to do is 3 5x and 9 2x minus 1. Now you know that 3 and 9 is divisible by 3, but you have this complicated equation, but don't let it confuse you. If I have, I'm not going to use orange because it's hard for you guys to see. Okay, so I'm going to take 9 again right here, and I'm going to try to make it into this base. So I'm going to divide it by 3, so 3 times 3. So that means this 9 is the same thing as 3 squared. So this is how I rewrite this. I have to be careful. This is 3 squared, and then I'm going to put these in parentheses and then attach it. Okay? Because that 2x minus, that 3 squared only applies to this. I can't change the value, and if as long as I get 3 squared and then this, I'm good. So I put parentheses here because I want this base to be the same as this, and I'm going to bring it down. Okay? Again, the most difficult part is putting it in that same base. After that, once I have the same base, I can bring down my equations, which is 5x equals 2x minus 1, and then from there, I can solve. So this is the most trickiest part. So you don't understand that, make sure you ask me so that we can go over there again, and from there we solve 5x. I'm going to distribute 2, so it's going to equal 4x minus 2, and then I'm going to subtract 4x from both sides. I end up with x equals negative 2, and that's my answer. So go ahead and write this down. I thought I had the answers here. Let me check my answers. Go ahead and write this down, and you're going to do problems 2/3, negative 2. Perfect. problems 2, 13, and 14. 2, 13, and 14, and see if you can apply the rules that we learned, and I will see you in class.